Okay, so this is topic number 5, forces. What we have to remember here is things like dynamics, F equals ma, all that stuff before we head into forces. Forces is all about one basic principle, and that's essentially equilibrium. So moving on. We got some images here. These things are essentially in equilibrium, okay? They're stationary, they're not moving anywhere. And there's two things that will define equilibrium, enable a body to be in equilibrium, and we'll look at those later. But an object is in equilibrium if there is no acceleration, either linear or rotational. So it's not just the fact that this object here may not be moving anywhere, okay? It's also the fact that this thing here may not be rotating as well, okay? So it's not rotating. This is a little pre-test just to see how good you are at the stuff you did in IGCSE in terms of balancing things out. So you need to answer the question below this video and put in what your answer is. Okay, in other words, is A an owl or is it the blackbird? Okay, you got to choose which one it is. Equilibrium is a point object. Essentially a point object will be in equilibrium if the algebraic sum of all its forces acting on it is 0. In other words, if you have this point here and the forces down are 10 and the forces up are 10, then they are going to cancel out, and this thing will either be stationary or it will travel at a constant speed or constant velocity. Okay, if we're looking at this one here, we've got some stationary. This block here is stationary, so that means it is in equilibrium, okay, because the forces pulling that way are equal to the forces pulling that way. So the algebraic sum of all the forces is equal to 0. This one here, we have acceleration to the left. This one we've got acceleration to the right. So these are not in equilibrium. So I've got this question here. Essentially, you need to draw this diagram in your books, okay, as an equilibrium example. Here we've got this yellow thing, we can call it an egg, and we've got 3 forces on it. We've got a 40 Newton force to the right, we've got a 30 Newton force that is going vertical, we have a 50 Newton force that's 127 degrees to the 30 Newton one. Now this is not a scale diagram. I have added in some vectors that are actually at the right angle. So this orange vector here you won't see in the notes that you've downloaded. It is one that I've put in because it's at the right angle. So if I'm going to add these 3 vectors together, I'm going to look for a resultant. Okay, remember you add head to tail for all vectors. Doesn't matter what order you put it in. So I'm going to put this vector back there actually, just make life easier. Put this vector to the tail of this vector to that one's head, and then grab this vector, put the tail of this vector to that one's head, and what you can see is we actually create a closed triangle. It should be perfectly closed. That's I might be slightly out somewhere. So this is a closed triangle, so there's actually no resultant force. Okay, so there's no resultant force, so that means there must be no acceleration. In other words, it is in equilibrium. If I had have done some vector addition, let's say with these 2 or 3 vectors here, and went like that, and then I could have done a resultant force that went like this, so remember my double arrow, then that thing is not in equilibrium because there is a resultant. But in this one, there's no space to put in a resultant force, okay, so the thing is in equilibrium. That's essentially what it says here, okay, so hopefully you've got a closed triangle. So closed triangles denote equilibrium. Now you must be careful that in terms of the exam, the examiner may draw some vectors, okay, for a question, and this might be something like this, and might ask, is this an equilibrium? And it's not, because it's not a correct vector triangle. If you added these three vectors together, if we put this one here in the correct place, which would be there, then there would actually be a resultant force. This is an experiment that you can do, that we'll do in class using a force table, looking at how three vectors can make a ring in the center in equilibrium, and how does the sum of all the vector sum of all the forces add up to 0. Now we might leave it there for the first video. The next video we're going to start looking at moments and how moments can be used for equilibrium.